Good day, everyone. My name is Chong Si-eun, and my FYP supervisor is Professor Tomoya Suji. Today, I'm going to present about my FYP title, Key Group Concept for Heavy Constant of Nitrogen and Oxygen Gas Solubility in Organic Compounds. What is free radical polymerizations? Let us have a look on this animation video. This is the monomer. There are three steps in polymerization process, which is initiation, propagation, and termination. Initiator is used to start the reaction. It will break the bond within themselves to form two free radicals. The free radicals will attack the other monomer and forming bond with them. For the propagations, the longer growing chain is formed by the free radicals of the monomers. In the termination step, for combination, the two growing chains are linked together to become the polymer and stop the polymerizations. For the disproportionation, the long growing chains attack the other long growing chains by taking the hydrogen from the carbon next to the active site to form a complete polymer, while the incomplete growing chains will form the double bond among themselves. So let's come back to our title. The oxygen is needed to remove from the polymerization process. Why is it so? This is because oxygen is abundant at the atmosphere around us, and it is very reactive and it tends to react with the initiator in the initiation steps as shown here. And next it will attack the monomers and reach the termination steps faster than what we expected. With the presence of oxygen, the polymerization process is hard to control because oxygen will react with the initiator and monomer, which cause the wide range of molecular weight distribution of polymers. Secondly, the induction time to start the polymerization is disturbed by the presence of oxygen. It will take longer time to start the reactions. Therefore, it is a must to remove the oxygen. What we can do is, we can bubbling the nitrogen gas to remove the dissolved oxygen in polymerization process. This is related to our study, which is to find the gas solubility of nitrogen and oxygen gas in different organic compounds. The key group is the organic compounds that are having the same molecular structure. For example, benzene, styrene, and divinyl benzene having the similar molecular structures as CHN, where N equals to 6 for benzene, N equals to 8 for styrene, and N equals to 10 for divinyl benzene. These are the proposed of the key group concept in the previous study. So in my experiment, I would like to propose the key group of MMA, which is methylpropionate, acetic acid, methyl acetate, ethylene glycol dimethylcrylate as the key group of MMA. The reason of choosing these derivatives is because they are all basic vinyl monomers, which is usually used in the polymerization process. For the experiment objective is to measure the nitrogen and oxygen gas solubility in the key group of MMA. Second, to investigate the key group for the gas solubility in MMA derivatives. If there is a similar trend for the gas solubility, we can assume that the other compounds that are having the similar molecular structure will also have the similar trend of oxygen and nitrogen gas solubility in this compound. So, third is to provide sufficient data for industrial use in polymerization process. The data can be extrapolated for necessary conditions such as the different temperature in the industry. So as far as I know, there is no gas solubility data in the key group of MMA that I proposed earlier. This study can make a great distribution to the polymerization industry. So how do we conduct this experiment? For the methodology, we will use the experimental apparatus as shown in the schematic diagram. So in addition, the glass cell is specially designed for this study and it can withstand the pressure up to 4.5 megapascal. That's all from me. Thank you for listening.